recording is on.
Okay. Can we do it? So I'm encouraging anybody interrupting me and asking questions. But in order for that to work, everybody has to be able to talk, and I have to hear them. So can we say hi around?
Is my audio on now?
Now your audio is on.
All right, I think I fixed it.
Great.
Yeah.
I'm kind of sad. I'm kind of sad that Oh, I see what happened. I'm kind of sad that Keith isn't here. But well,
Yeah, he must be a user.
I mean, he's a Lisp guy too. So anyway, so I guess we can. Oh, here's Keith. We were just talking about. So going around, I'm the current WLUG president. My name's Tim Keller. You guys have known me for 20 plus years. Been the long-running president. Kalman is my coworker who'll be doing the talk. Josh Stone is another guy who Chuck's here. Who has been organizing our on-prem meetings when we actually have them. So
I like the badge for Peach.
I know. Beach visited network operations enough times so that they made her a badge.
Yeah, we had a couple of dogs at Symbolics when I worked there that had badges too.
Hey, Keith. Oh, how do we go around in a circle here? Because I'm sure all our circles look different.
Oh yeah. So, well,
I would do it alphabetically.
Chuck.
all right. Well, we have. Well, so doing the participants, we've got WLUG. Or we have me. I just come up as WLUG meeting. So Doug Mulgrim, say hi.
Hi. And hi, Chuck. Next, Ron, maybe?
Yeah.
Hey.
Next is Ron.
Hello.
Yep. Next is John.
Hi there. Can you guys see me?
No.
I can't see you.
We cannot see you.
Hold on.
We
Next
can
we
hear
have.
you. That's good.
Yeah.
Oh, you
Next
can
we
hear
have.
me. Good.
Oh, there you go.
Oh my God.
Sweet.
Next we have Kalman.
Right?
Andrew. 3.
Andrew's icons look like they're muted and no video.
Yep. Okay. Fair enough. Yeah, it looks like that's the case. Chuck. Joshua Stone, who looks like he's also muted and no mic. Fair enough. And rounding it out is Keith. Right.
Can
Keith.
you hear me?
Yes,
Hey,
we can.
you hear me? Okay, good.
Excellent.
I'm using a borrowed Windows laptop here that I've never used before.
We won't judge you too
already.
harshly.
It sucks already. But
well,
the
you are
camera on
WLUG
my other
meeting.
machine is, I don't know, it works even worse.
All right.
Probably
Well, why
time
don't
to
we?
blow it away and reinstall. I know that's kind of a crappy
No, I
answer.
think it's hardware.
Yeah.
So I'm going to start sharing my screen, if that's all right.
Sounds great to me. We got Al as well.
Oops. Hold on a second. Why did it not work? There. Okay. So, you should see mostly white.
Yes.
I can't see what you're seeing. So. Anyway.
Emacs for fun and profit.
In other words, how it fits my professional life is a lame attempt at it. So, we're looking at an Emacs. This is actually on Windows too. But almost, in fact, everything that I'm going to talk about would work on Linux too. The reason I did this is I have a little program on here that's called Karnak that lets you see the keystrokes I'm typing. So I don't know of such a program that works on Linux, but this is really cool. So when I'm typing things fast, you can follow along if you're so inclined. Anyway, just to start things off, a little bit of whiz bang. So my name is Kalman Reti. I work at Ab Initio with Tim. I've been there almost 20 years. I think it will be 20 years in June. Before that, I worked for various different incarnations of symbolics and also Apple. There was a research lab in Cambridge that worked on Dylan, and I was at that. And then before that, I worked for DEC. Before that, I worked at a community college in Philadelphia on an IBM 36030. Long history. So, anyway, the point of this talk is to basically describe some of the things that I do with Emacs that you might not expect that you could do with an editor, like that fancy title. And I also wrote a keyboard macro, which you'll see me invoke as Control-X E, which goes down this org mode is this sort of outliner. And so it goes down the outline, opening up the various pieces. And one of the cool things about keyboard macros is that the first time you have to type Control-X-E, but if all you're doing is invoking it again, you just type E. So you just keep typing the same character over again, and you get nice behavior. So
is that in all? I'm sorry to interrupt.
No, please interrupt.
I use Control-X, left paren to start a macro, and then Control-X right paren to end it. Because I'm an Emacs user editor. I write email in Emacs and all that fun stuff. But I'm certainly not a power Lisp user because I'm horrible at Lisp. But I'm amazed that E repeats a macro. I got to remember that.
So Control-X-E is what you use to invoke it.
Yeah.
And in more recent Emacs, and this wasn't true in the dawn of time, you see how at the bottom in the mini buffer it says type E to repeat the macro.
Yeah.
So if I type E, it'll repeat the macro. If I do something else, if I do Control-N's and Control-P's to move around, then I'm back to having to do Control-X-E to do the macro.
Right.
So I'm a multi-platform developer. I work on Unix, Windows, ZOS, and various other platforms. And even the Unix parts are variants. We have AIX Solaris, Cygwin on Windows, and USS on the mainframe, C++, all these things. I also do a lot of sysadmin type work. And then I also do a lot of authoring of various technically type stuff. And the final thing is I do some programming for fun. And in particular, I did all of Advent of Code this year. I didn't get all the 50 stars, but I mostly due to time constraint. But I did all of it in Emacs Lisp on a tablet on Android. And all but about 10% of the time I spent on it was under the covers in bed in the morning before I got up and went to work. Anyway,
I'm still on day 4.
So anyway, the whole point of this talk is to show the sorts of things that I do. There's many of them. If you're not interested in something, tell me to skip it. All of the, Emacs lets me do them well. So I'm going to talk briefly about some Lisp and Emacs history that's pertinent to the types of things I do and why they can only be done in Emacs and Lisp. And then after that, I'm going to give some examples of the types of things I do, and I can demo some of them live. Some of them I'll have to just describe because while I do them at work, there's, the work environment's not available to me at the moment. Anyway, Lisp was created in the 50s. It ran on an IBM 709. It has greatly evolved, but one of the cool features is that it's extendable sort of seamlessly. And the name stands for Lisp processing, and it's named after its most salient data structure, namely a list. And a list, so I always do this thing. I forget that I had typed another command, so I typed an E when I didn't want to, which inserted an E, but then I undid it. A list is nothing but a string of conses, and conses are nothing but a pair of pointers. The first pointer points to the current element of the list, and the second pointer points to the cons that represents the rest of the list after the current element. And if there's no more in the list, then it points to the empty list, which is also known as nil. And this is a very complex, compact data structure. There are just two words each cons, and you can stick things in the middle and things at the end. And this was extremely important because, one, you can do efficient operations on the slow machines of the day, and two, they didn't take much memory. These machines had, a few K words. A few K words at most.
Right.
So
And it's type safe, isn't it?
Sorry,
right?
what?
It's type safe because it doesn't really.
Well, it has
care
runtime
what-
typing. So the idea
Okay.
is that the plus instruction works on any kind of number because each number is tagged with the type it is. So you can add two integers, you can add two floats, you can add two complex numbers, you can add two big nums with the same plus because the type information is carried around in memory.
Cool.
But the in-memory representation of a list is pretty simple, just a string of conses. The external representation, what you use to print and read them, is also very simple. It's just an open parentheses followed by 0 or more elements of the list. If you need to separate them, you separate them by spaces. And of course, you can have nested parens, and those don't need spaces. And at the end, you have a close parenthesis. It's extremely simple to parse and extremely simple to back out again once you've parsed it. And so what happens in most Lisps is you have I get a little out of order. You have this thing called a read eval print loop that's at the bottom of there. That's going to take in a sequence of characters that you type in with read, return a pointer to the list structure in memory. Eval is going to take that list structure and evaluate it and return back a pointer to the list structure of the answer. And then print is going to take that list structure of the answer and traverse it, printing out characters that represent that. And the most unique feature of Lisp is that this data structure, this list data structure, is also the language's expression, data structure. Expressions in the language are lists. The only thing that's different between a data list and an expression list is the first element of the list is assigned a semantic meaning, namely it's the operation you want to perform, and all the rest of the elements, if any, are the arguments to that operation. So now, because the evaluation is working on the internal representation, it allows the normal evaluation that every language does, which is, figure out the operation, make sure the arguments are congruent, recursively evaluate all the arguments, collecting up the values, and then apply the operation to those arguments. That's the standard normal evaluation. But Lisp, because it's operating directly on the data structure, has a second type of evaluation possible, which is called macro expansion. And the operation gets the entire structure of the invocation, exactly what was basically typed in, as its single argument. And when you're doing a macro expansion, the goal of the macro expansion function is not to return a value, but to return a new list structure that's been transformed that will get evaluated once again. So this allows you to rewrite code. That's why it's called macro expansion. And it's an extremely powerful mechanism that's not possible in other kinds of languages. And most of the time that I'm using it, eLisp, or actually any Lisp, I'm using two macros in particular, setf and friends, and the loop macro. And what setf and friends are is they're what are called generalized accessors. So let's say you have a structure that has as a member of one of its slots another structure, et cetera. You'd have to have a nested sequence of operations to get to the innermost thing that you're interested in. if you want to change that innermost thing, you'd have to have a similarly nested all the way down to the bottom, but then replace the bottom access with a put, basically. What setf allows you to do is you say setf, you code the exact accessor expression, and then give it a value after that, and it figures out how to do the put part, after accessing all the rest of the stuff. And it's completely general. And I say friends because there's incf for incrementing and shiftf for having a bunch of them, where the values get moved down, from left to right, from right to left. Anyway,
is this a common Lisp or eLisp? And
so it's common.
And I have one other little comment, is that you might want to back up a little bit to give us some simple examples of using Lisp, because God knows I'm kind of lost.
Okay. So if you look at the bottom of the screen, oops.
Yep.
Let me undo my. Look at the bottom of the screen. I'm typing in an operation. This is a symbol. Plus is a symbol. There's no syntax for symbols. They're intern. That means every time I type in plus, the reader will give me back the same exact symbol object. 1, 2, 3, 4, 5. Close paren, and I get the answer.
And
Metacolon,
so
which is the
OLF and all that on the bottom that it came back afterwards, is that part of the eLisp, Emacs sort of debugging, or
whenever you print in the mini buffer an answer, eLisp will print various, and that turns out to be a number. It'll print 3 different formats. The first is that same number in octal. The first one was in decimal. The second is that number in hex, and the third is that number as a character.
Thank you.
And that's an Emacs feature.
Okay.
We can do other things. For example, I could go into this scratch buffer, which is for and say buffer list. It's an Emacs function that just gives a list of all the buffers, and here they are. And in here it says ... because there's a limit to how deep and wide you can print by default. But if I hit return over there, it then prints it all.
Okay.
And moreover, whenever you do something with metacolon, the answer that you get is pushed onto a list called values. So if I say first of values here, I'll get back that 15, which was the answer for the previous expression that I typed.
But that's not the previous buffer list thing.
No, because Scratch is for evaluating expressions and returning the answer in the buffer. So it doesn't participate in the values thing. When you are using
values is just down in the mini buffer.
Right. When you're doing this eval in the buffer here, that does. So if I say, times. Notice when I typed it in, anytime I'm going here, I can do meta P to yank back the previous thing. So I can go backwards, and I can go meta N to go forwards. There's history kept for lots of things. The little enunciator on the right says Alt P because the meta conceptual key is mapped to the Alt key on this keyboard, and in fact, in most modern keyboards. But there are lots of older platforms that had actual real-life meta keys and/or were missing either, and so you had to use different mechanisms. So I'm always going to say Control and Meta, even if that's not the keys that we're using. Anyway, that's trips of the bugger. So anyway, loop. We're going to have examples of setf and loop. So have no fear.
Thank you.
Meta means alt, right?
Sorry, I didn't catch that.
Meta means alt on a real keyboard.
What I was saying is that Emacs is going to talk about it as meta. There are various ways that you can make a meta keystroke. So, for example, on very impoverished keyboards that don't have an Alt key at all, or where the
Yeah, I understand all that, but it's Alt now, right?
It's Alt on most keyboards, yes.
Right. Yeah. Okay.
But that's the only one of the way. So, for example, if I want to do Control Meta F, I can type Control Alt F like that. I can do Control Meta B to go backwards, but I can also type Escape first and then Control F, and that's the same thing. That combination of two keystrokes is equivalent to Control Meta F.
That's what I normally do. Is I'm so
well,
bound
so
up.
the problem with that is that if you're typing a whole bunch of Control Meta sequences, the way you type it, if you have an Alt key, is you hold down Control and Alt and type the things. So you can go F, 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 B, B, up, U, a whole bunch of them. Whereas if you're doing it with the escape in between, you have to go Escape, Control F, Escape, Control F. Yeah.
Right. No, I just find it hard to hold both of them down because I will throw down the Shift key at the same time or the other Control key, or it's.
And doing things on the tablet makes it even more interesting.
So as a funny side note, lots of people at Ab Initio are huge Emacs users, and particularly one of our coworkers, this guy Al, who works from home. He had a funny situation when he was in the office, in that he had a particular keyboard he loved, but he managed to wear out the Control key. He wore through the Control key, and but he loved the keyboard so much he wouldn't get rid of it, and so he dynamically remapped Control to be the Windows key, because he was running on a Linux desktop, and so for him the Control key just became the Windows key, and it was just one of those funny things where nothing is set in stone, and he was happily willing to work with that. But it was kind of funny to just on the fly just shift around what your meta and your alt keys are.
Yeah, lots of people put.
Speaking of funny,
similarly.
Speaking of funny, I have a kind of a cartoon picture. The caption says "Emacs user at work," and the picture shows an octopus kind of going like this on a keyboard.
So
you
one of the
problems
is not Emacs, it's the keyboards. Back when Emacs was invented, the keyboards had Control Meta Super Hyper on both sides of the spacebar, right next to each other in a row. And so doing those, and then Shift just above. And so doing those keystrokes was convenient and didn't hurt. But of course, people aren't doing that these days, and so the keyboards aren't set up that way, and so now you have to type on keyboards that really aren't meant for this.
So like I started on the VT100s and the VT220s is where I learned Emacs, and then like micro Emacs on my Amiga.
Yeah.
And I curse everyone who puts every keyboard that has caps lock on the home row instead of Control key, where God demands it should be built.
Well, as I said, there's a lot of people who map Control to caps lock. You can do that with Xmod map easily.
Yep, that's actually, I have a keyboard, the code keyboard, which is a mechanical thing, and it's got a switch that just automatically makes the caps lock key, be a Control key, which is fabulous because I can plug it in and it just works.
So that was my little section on the history of Lisp. And so here's a little on the history of Emacs. So Emacs was actually invented with ITS TICO at the MIT AI lab, long before there were keyboards like you are used to. And in fact, Tom Knight made the first keyboard that they ran on, and it was called the Tom Knight keyboard. This is long before mice were a thing. It was just when the first bitmap displays were being a thing. He also invented the first bitmap display used widely at MIT.
But those keyboards were very uncommon. You might have had them in the AI lab, but DEC didn't produce them, and DEC sold millions of terminals.
Right.
Yeah, the VT100.
But DEC didn't have Emacs either.
We certainly did. I used Emacs on a VAX. It was essential. I was writing Lisp in the mid-1980s, and you might have the matching open paren off screen, but in Emacs, when you type the close paren, it would bounce back and show you your frame of reference, and it was so valuable.
Oh my God, yes. Even for just regular C code or something, electric parens is a godsend.
In any case, if we talk about on this long on every point, we'll be here till midnight. Anyway,
That's okay.
so before what my point is that Emacs is keyboard oriented because the types of editors before Emacs were run on teletype like terminals, or the LA whatever it was that Deck made, that had paper, fanfold paper going through. And so the only cursor change you could do is go to the beginning of the line and move down one line or multiple lines. So you had to have sort of a separation between what was there, and you could print a range of lines, and what you did to affect them, which was type in cryptic keystrokes that did things. But because Emacs wanted to run on terminals that had cursor, glass TTYs that had cursor ability, the modal nature of those other editors wouldn't hack it. In those editors, if you were in insert mode and typed the D, you got the D in the buffer. If you were not in insert mode and you typed the D, it deleted a character. And what Emacs does instead is use the modifiers. So modified keystrokes are editing keystrokes. Unmodified keystrokes are by and large plain and go into the buffer.
Right.
So the common modifiers are Control, Shift, and Meta. As I said, there are also super and hyper. But and moreover, there was some amount of care to try to make mnemonics for the keystrokes and to make these hierarchies. So Control A goes to the beginning of a line, Meta A goes to the beginning of a sentence, which might be a few lines up. Control Meta A goes to the beginning of a definition. This still works in C, for example. Control F goes forward a character. Meta F goes forward a word. Control Meta F goes forward a whole expression. Control T transposes two characters between the cursor. Meta T transposes words, and Control Meta T transposes whole expressions. And so you had these sort of hierarchies of keystrokes. But the thing that's unique about Emacs is that every single keystroke runs a function. If it's a plain character, it runs a function that'll self-insert the character that you typed. But every single keystroke runs a function. And for every buffer, there's a mapping called the key bindings, which says for this key, run this function. And that's controlled mostly by the major mode. Each buffer has exactly one major mode, but it can have additional minor modes, which you can add, remove, or change the bindings. But a consequence of the fact that every keystroke runs a function is that anything you can do via keystrokes, you can also do programmatically. This is not true of most editors. For example, Control N, which moves to the next line, and I'm typing a few right now, is basically the same as typing next line. Easier to type, but it does the same thing. Now, another thing is that most keystrokes can take numeric arguments. So if you wanted to move 3 lines, you could specify a number. And there are many ways, but Control U, Control 3, Control U 3, Control B will go 3 characters backwards, or Control 3, Control B will go 3 characters backwards. Either way is a way of specifying a numeric argument. There are many terminals that won't actually accept Control 3. So, the Control U way is the way that most people will use it. But these numbers can also be negative. So you can say, go -3 forward, which is the same as 3 back. And in fact, I use the negative modifier a lot because, for example, Meta U will uppercase the following word and move past it, whereas minus Meta U will uppercase the previous word. And then the cool thing is Control U without a number means multiply the number by 4. So if you say Control U, Control N, you go down 4 lines because the default is to go down 1 line, and multiplying by 4 gets you 4. But Control U, N goes down 16 lines. And so navigating up and down inside the buffer is a matter of doing Control U, Control U, Control N, or Control U, Control U, Control P. And if you overshoot or undershoot, then you do Control N's and P's to get yourself to the right place. Now, again, this is not hard to do because you're holding down Control the whole time and just doing NNN, PPP, or whatever it is.
Right.
And this is generally faster than moving your hand off the key, clicking on the mouse to put where you want to go, and then coming back to the home row so you can continue typing. So,
Yep, absolutely.
Yeah. So another thing that's a sort of a distinguishing feature of Emacs is that it has incredibly extensive help. So there's the info manuals, MetaX info, which are just English written manuals that are inside of Emacs. There's a really good one on Emacs itself, the keystroke bindings and how you use those. And there's another one on eLisp itself, which is also quite good. And there's a tutorial that goes through baby steps through their first uses. all in the same info facility. Plus, there's lots of stuff on Unix commands, grep and most of the Unix command Linux command facilities are also in info. There's this Control H. If you type Control H, question mark, it tells you all of these different things that you can do. That's quick access to various kinds of help. I'm going to abort it. So I'm only going to mention a couple. Control HB gets you a list of key bindings. Control HB. So this is the key bindings. If I scroll down here, you can see that all of these different keystrokes will run different functions.
So Control Meta V will scroll the opposite buffer?
Yep.
Huh. I always do like Control XO and go into the other buffer and scroll.
Most people do, but
yeah.
it's not as good.
It's interesting. I think one of the questions I've always had about Emacs is if anyone's ever done any sort of sampling to figure out what keys are used the most and what's the distribution of keys, because I'm sure you're using a certain set of keys and I've been playing on my keyboard a little bit here trying to figure out which is my meta key, which is my alt key, but it's in an awkward position to sort of, since it's under like the Z and the X on my keyboard, it's kind of awkward to hit meta and to train my hands to do it.
Yep.
Where I almost think that lower left key might be the better thing with meta down there to take my, but yeah, I don't have a good answer.
So the thing is that because I'm doing eLisp a lot, Control Meta type of commands are a very large proportion of what I type, and having Control and Meta be both on the same row makes it easier to hold both of them down. So in any case,
no, that's a very valid thing. I'm just not sure I can train. I have my pinky trained to do Control.
So about training, it's quite remarkable how you think it's hard to learn new habits, and it starts out being that way, but do it for a while and it becomes remarkably easier, especially when you get the task X done in half the time. Anyway,
no, it's a good point.
So the other thing is that there's even more help. Every single symbol that names a function that's being used inside of Emacs is searchable. MetaX apropos is basically a regex search of all those symbols. And what you do if you say MetaX apropos, let's say property, get back this help apropos buffer. And here I do have to go into it because I'm going to actually go. So add text face property. Sorry, I moved past when I didn't want to. Mistyping. If I go Control F to go on this function here and hit return, it's going to take me to the help for that particular function. And moreover, it tells me, how to use it. There's nice information there. But it also, at the very beginning, tells me where it's defined. Up here. Why is this key doing the wrong thing? See where it says source text prop. So unfortunately, I do have to do this once. I thought I had done this already, but users. I think it's this one. Ah. Okay, well, I have lost it. We can do it if I do it apropos of meaning.
So Kalman, it should be noted that every single demo inside of WLUG has one thing that goes wrong. So
One?
it's sort of it's
At least one.
so yeah. So it's the fine tradition of WLUG that your boot disk will be blank, your computer will catch fire.
Okay,
You know,
so
usual.
this one is an eLisp file. And so I went there and it took me to the function that I named. And if I look here, that's actually the path that I wanted, that I was trying to type. And I don't know why I didn't quite make it. I can just copy it and go back to the.
I do love having all the different buffers. It's
I'm wondering where those cute pop-ups come from. They seem to get better and better.
So that's a program called Karnak. It's a Windows program. It tracks the keystrokes and it puts them up on the screen and then lets them fade away.
Outside of Emacs?
No, it's outside of Emacs.
Yeah.
It totally. I don't know of something that does this inside of Emacs, and I also don't know of something that does this on Linux. There are Mac OS programs that do this too. If you look on a whole bunch of Emacs videos, we'll have a similar thing. But anyway, apropos, let me go back to my talk. I've been sidetracked for too long on this. Okay. Apropos. Anyway, if you put the source hierarchy into, as a sibling directory to the Lisp directory, then you can go into those source C source functions as well. I really do want to do that. X. Oh, another one, another help, control HF forward car. Okay, so that is, okay, I'm mistyping. Okay. So here, because I had put on the kill ring the eList path, I could yank that in and modify it so I got the source path. This is a Lisp function defined in the C code, so that's all accessible there too.
neat.
But you have to do that step yourself. The no distribution puts that source file directory there. So where were you? We were at apropos. Okay. So flexible data handling is another thing about Emacs. You have all your data in buffers. You have lots of buffers. They can be used for just static data like files and or that you're editing, change, or it can be for active data. So you can run sub processes and hook their input and output. So medx shell will run a shell, and you have pipes back and forth. Medx r login will log into a remote host, and the SSH client or whatever that's being run to do the R login, it's a child of Emacs, and it's hooked up so the input and output go to the buffers. One of the cool, I'm going to start up a shell. I already have one. One of the cool things about shells is if you type in a command, let's say, I don't know what, this is a Windows machine, so this is dir Okay, so I typed in a command. Control C, Control P goes to the previous input. Control C, Control P. Control C, Control N goes the other direction. And so the idea is that even if you've done lots and lots of outputs, you can go back to the beginning and search forward, so for something, and be sure that you're only searching the output from that command forward.
Nice.
You can
I've
also
tried using it in the past, but I found meta shell was just painful at points.
du-k. So here I am. This is actually going to be part of a later example, but notice it's still going. I can go backwards and start looking at it while it's still running. You can see down at the bottom it says shell run. That's because the command is still going. I'm beginning to look at these results while the command is still going. And in fact, I can do things like I can do a regular expression search and say I want to look for everything that's a sort of a second level directory. So, oops, I typed one character wrong. I'm going to use a non-remembering grouping. That's what the question mark colon is. And what I'm going to do is I want a slash followed by any number of not slashes, more than one, and the grouping. And then I want exactly two of those. I'm going to use the exactly two repeated. Oops, I typed the wrong parentheses. I want this curly braces. Two curly
The
braces.
magic of regular expressions.
And then the end. What did I do wrong?
Is the dollar sign on the end to match the end?
Yeah, the dollar sign is to match the end, but the dot dot. Oh, dot dot's a special character, right? I have to. So when you're in the middle of this regular expression, you say meta E to edit it. So I just need to, and then you just type Control S or Control R to continue the search after you've edited it. So here I am saying I'm only looking at the lines for 2 down because there's going to be lots more lines of the subdirectories. But this is a big one. So I know if the command were still running, but I was trying to remove files, clean up files, before the machine died, I could be doing this, in situ, looking for some good candidate. In fact, I did exactly this on a machine of a colleague yesterday. And the thing is that if you were doing this, the traditional Unix style way, you would have said du-k pipe to sort-n, but that won't produce any output until the very end, so many minutes from now. Whereas this, you can start finding useful information and maybe even acting on it. Now, I have a shell buffer here. It's still running, but I can say Control U Metax shell. Oftentimes, you can use Control U to affect the behavior of a command, even though it's not taking a new argument. The affected part of the behavior is it's going to ask me for a new buffer name. So I'm going to call this next shell. So now I have 2 shells running in the same thing. So I could start doing some of the cleanup. And this guy actually did finish. So one of the things we can do is we can say, okay, starting here, I'm going to mark Control space marks, and then Control C, Control P goes to the beginning of the command. And I'm going to say mark here. Then I can say metax sort numeric fields. It's sorting the first field, but I could tell it which. So now I can do the equivalent of the sort-n, but I've done it in Emacs after the fact. I don't know if that's interesting to anybody.
I think it's I do that myself at times. I certainly find Emacs a lot easier to do major text search and replace if I'm not doing like a set or a awk, or if I'm editing text at times, because VI just makes my brain hurt too. I think Emacs is just amazingly powerful. It's a matter of finding everyone's comfort zone inside it. Here's a question. Do you use the shell buffer all the time for your terminal windows when you're going out to other hosts?
Yes.
I tend to use
I use an rlogin buffer. It's not the same shell buffer. So I don't type SSH in the shell. I type medx rlogin. Right. That runs what's called the rlogin program, which these days is SSH. Right. And it makes the connection directly to the host, but it has the same properties. Control-C, Control-P works. It does track the directories. So if you're CD'd into a directory and you say CD ABC, then it'll remember that you're wherever you were before plus ABC.
Because I tend to use Xterms with shell screen running inside it to do my remote access. But I do miss cut and paste into Emacs for editing.
We're getting a little ahead of ourselves. But one of the things that I do a lot is I build on lots of different platforms. So I'll have our login, sessions to a dozen different machines, and I can arrange them in a nice grid. And then I can say, I'm going to send the same command to all of them. So I can, update my sources and, run the same build command or run the same test command, or I can search for a particular test failure in all of them by just typing one command, and it then, elisp is sending it to all of the subbuffers, which is not so easy to do in Screen.
No, it's friggin' impossible, but I love Screen because I can actually I can do SSH all over the place, and I can bop back and forth without having to move my hands off the keyboard and, find the mouse to click on a new window or a new terminal.
Well, as I said, I have them all as separate little buffers in the same Emacs, so I don't move my hands off the screen either, off the keys either.
Yep.
So anyway, not only do you have lots of buffers, but you can even have multiple windows to the same buffer. So if we go back to the shell, and if I type another dir here, I did a dir earlier. So I can say Control X2 to split it into two different windows viewing the same buffer. If I go Control-C, Control-P, that's the dir I just typed. Here's the older dir. And now I go back to this one and just go to the first dir. I can say medx compare windows. And what it does is it takes me forward in both views as far as they are the same. So we noticed that on the other one, we stopped when there was 49, we got to 496 here. And here we stopped when we got to 261. And if, for example, you're trying to see what's happening over time, you could do periodic PSs and compare them and see, what new processes are running or how much CPU time difference there is among different processes. I use this trick all the time.
That's fantastic. Will that work between any two buffers?
Yes. Well, it works on Windows. It's compare Windows. So yes, one could be a file, and one could be a listing. One could be whatever you want. If you're at corresponding places in the two windows, medx compare windows will move forward until it no longer sees them being the same.
Cool.
And in fact, if you want to look, so one of the things you can do about apropos is you can use regular expressions to compare windows. And so you can see there's a whole bunch of them. But if we go here, you can see the actual code that's running. Now, one of the things that's great about having the actual code is you can modify it. One of the things about Lisp is that it calls functions indirectly through their symbols, which means that you can make a redefined version of the function that captures the old definition, but updates the function pointer that's in the symbol with a different definition. And so every subsequent call goes through your new different definition. And there's a built-in facility called advice that allows you to wrap either code before the call or after the call or around the call. And so you can look at the args before you call the original stuff. You can modify the answers. It sends it back to you, or you can even avoid the calling the original function itself. So you can make changes to the behavior of built-in functions even without actually modifying the code. Because if you modify the code, then you have to keep that modified code, and of course, the next version of Emacs will probably have changed it. Anyway, getting far afield here. So another thing, besides having multiple windows on the same buffer, is that the buffers have what are called text properties. So if I say text properties at point is the function which returns the current cursor position. So it says we have face named org level 3, and we have fontified T. If I move down here, oops, again, I'm taking the wrong thing, and execute the same thing, we just have fontified T. There's functions for moving till the next change of properties. There's functions for moving backwards and forwards till the next certain particular value of a particular property. But properties can tell you how to do things. So many properties are used by Emacs itself. So the face property tells how to format it. And it can have things like the color and the font size and all that sort of stuff. But there's also a property called invisible, which we'll see later. And you can use your own properties for anything you want. So you can mark different bits and pieces of your output in
That
different
is
ways.
a really cool command. So can it tell you how to get to a certain face or property? Like,
Yes, you could. So I just did MetaX info. Notice here's the eLisp, and I'm in the eLisp, and so properties. So somewhere text properties. There. So this tells you all of the functions, how to examine them, how to change them, how to go from one to the other. Info is really great because you just type space and you get to read the whole thing.
mm-hmm.
Anyway, and not only can you change the text properties of a buffer, but there's these objects called overlays, which span a range of a buffer, and you can change the text properties on the overlays. But the reason that's cool is that you can basically enable and disable the overlay. So in fact, when you do searching and it's changing the colors, I searched for space and notice that the first space is the purplish color and the others are the bluish color. Those are done by overlays.
Interesting.
And you can use your overlays yourself. I once had a situation where there was a trace from our software that the customer sent in that had, gazillions of instances of multi-line, uninteresting, boring stuff. And what I wanted to do was do a regular expression match, a multi-line regular expression match, and basically make all of those invisible, but leave behind a little thing that displayed saying, I elided 400 of these, or I elided 20 of these, or something. Right. And so I made the actual buffer have the text property that said invisible for this whole range, but I added an overlay, and there's properties you can put on the overlay that says basically display before and display after, and put arbitrary stuff to display. So properties. Okay. So I think I covered all the stuff that's in there. So there's also little known useful key bindings that I wanted to mention. Control meta V we already saw, as well as the other window. Control U, so I've been using meta colon. So if I say, let's go to another buffer. So if I say meta colon plus 1, 2, 3, I get the answer down here. But if I say control U meta colon, plus 1, 2, 3. The answer gets inserted in the buffer, which is really cool. In fact, that's how I put my answers into the buffers for my advent of code stuff. And sometimes, though, what you're evaluating is something that prints a bunch of stuff rather than returning a value. Well, there's a function called with output to string. So if I just say format get back a string. If I did that in my foo buffer, sorry, and said, oops, I didn't mean to do that.
You're doing
Control U metacolon, do that. It's going to return the nil. No, actually, sorry, I lied. It's actually returning the string. But if what I was doing was printing, if I was doing printing, print returns it too. Never mind. Anyway, the point is sometimes functions that do a lot of output, but you can wrap them around with output to string, and that'll capture the output and turn it into a string, and then that gets inserted in the buffer. We talked about Control C, Control P. One of the things I've seen people do all the time is they go over. Let's go to foo again. We don't want foo. We're in foo. We only want to go back to dotalk.org. What I'll see people do is they'll Control X0 to go to the other buffer, and then Control X1 to make it the only buffer. But Control X0 will make this one go away.
You have just taught me something that is going to save my life. That's awesome.
And then, of course, Control X3, which is underutilized, it splits the window, but it splits it the other way. And a curious story. I'm one of the people who can do both cross-eyed and divergent-eyed stereo viewing without any aids. And so very frequently I can take these two and cross my eyes and say, these are identical, because if there was even one character out of place, it would show up as either a fuzziness or something at a higher or lower level.
You're the human diff.
Yes, exactly.
You need to go to those twin conferences where they have all the twins show up, and you can just compare them.
So the other one is I mentioned some of the control meta F and control meta to work on whole expressions at a time. But if we go to something that has Lisp code, where do we have Lisp code? Oh, we have Lisp. No, we don't have much Lisp code. Again, I'm getting ahead of myself. Here's something which Lisp code. So if I want to do the whole expression here, just one keystroke, control meta at will mark that expression, and meta W will put it on the kill ring. Oh, and I did mention meta N and meta P in the history. So one of the things that's cool, for example, set frame font. You want a font name. These are enormously long, strange strings. If you did meta P, that would get you the previous thing in the font name history, which almost surely there's none. But meta N got preloaded with the current font in case you wanted it. So if I say meta N, it now shows me the current font. And so if I wanted to make it bigger or smaller, I could just search for the number part and then replace that. This starts out in Emacs as, at least this Emacs, as 13. I've already done this once, but the meta N as the preloaded, as if you had it there, gone back, but now it's still there available to get, is a useful thing. Control space is pop the mark. So if you do control space, sorry, I typed that wrong in my thing. It goes back to the last place you were. Where is it? Yeah, okay. No, So
I'm going to put
control
control
space.
U.
Yeah, it's control U, control space. Sorry, I'll actually say that. And this one is undo. I should have admitted that. Undo works in an interesting way in Emacs. Undo keeps undoing until you get to a point where there's no more undo history. But if you do another command that's not an undo command and do an undo again, then it does in the other direction.
Mm-hmm.
So there's not many programs that function that way. Okay, so let's go on. So those were my grab bag of little known keystrokes that I find useful. There's two little known functions that I find extremely useful. One is send invisible. If you are in a shell buffer or an SSH somewhere else, and you're being prompted for a password, most of the time in Emacs, there's a regular expression that matches those password prompts, detects that it's happening, and then it prompts you on the mini buffer and hides your answer and then sends your answer down. But depending on how weird your platform is, it doesn't get them all. So for example, with FTP on the mainframe, that regular expression doesn't match it. So instead of having to actually type it in the clear in the buffer, you can use send invisible, which we can show working by going to the shell buffer. Send invisible. Which takes an optional prompt, so I don't need the prompt. I know, dear again. So it prompted me in the mini buffer and then sent it.
Could you show us how it works with your password?
After I type the magic keystrokes, it turns out the enunciator. Yes, there is a keystroke for the enunciator that you type, and then it won't enunciate until you type that keystroke again. Exactly for that purpose. And the other one is kill backward up list. I think I maybe mentioned this one already. I did. So, okay. So this is sort of the meat of this, a sampling of the things that I do. I just, off the cuff, there's dozens more that I didn't have time to look out. And many of them I can demonstrate at least partly. Many of them I can't because they require resources that I don't have access to. So, and I think I mentioned this one before. If you have a log file that has all these uninteresting lines, you can do something like let's go to here. I say I'm going to start here. I'm going to say, one of the things I should have mentioned is registers. Registers is a real cool feature. Control XR is all the bunch of register commands. I can say, save the current position in register A. The space was the save the position part. The A that I typed afterwards is the name of the register. They're all just one things. And then I can say, Control XR space B. And now registers A and B have two positions in the buffer. So I could do get register, A and get register B. I can say put text property from get register A to E invisible E. And so I don't know how many times I've done this where I'm looking at a log file for something that might explain some strange behavior. There's all of these red herrings and chaff that you have to winnow out. So I'll find a whole bunch of the chaff, and so let's the way I find the chaff, I do something like loop for position equals search forward regex dot star dot sorry el. So if I just did that, if I didn't find it, I'd get an error. But I now put in a nil. That's the limit of the search. I don't want it to be limited. Notice these are optional arguments. It says regex, but then it says optional bound and no error. The bound part would be I only searched this far. The no error part is that I want it to not give me an error, just return nil when I don't have it. So I can say search for position equals. So this is the loop macro. I'll explain this a little bit. So the loop keywords are sort of very stylized. So a for clause makes a variable that's going to be updated each time through the loop. And so a with clause, on the other hand, makes a variable that is, around the loop, lives for the entire duration of the loop, but isn't changed unless you change it in code. So search for regex is going to return the position of what it found with the cursor positioned after it. Let's put a space in here. And there's also whenever you do a search of any kind, regex search, sorry, you have these match functions. It remembers what matched what. And so if we had the parenthesized submatching things, I used previously the question mark colon one, which doesn't remember. But if you don't use the question mark colon ones, it'll remember. And so you can get all of them back afterwards. So for position, that while position, what that means is that if position is nil, we didn't find it, we're going to exit the loop. So then for name equals match string, and last time I used match string 0. Match string 0 is the entire match, but which is what I have to use here because I didn't put it in a group parentheses. So that'll have the space in front. Do push new name onto files test equal. Finally, else. So that, oops. So what you're seeing is that not only do the buffers have properties, but so do the string. So that string no properties will return the string without the properties. Oops. And of course, I had moved, so I'd moved past the last one. So anyway, you can see that all of these things that I type, I type it in. A loop expression like that doesn't take very long. If there's a slight error, you yank it back in, but you navigate by whole sub expressions at a time. To edit it and change it and try it again.
This is almost. It's almost like writing like long expressions in Excel. When you hit F2 and you start editing these long expressions with.
But you can't yank them back and make a small change.
No, I know, and I admit this is a huge improvement that what I can do here, what you can do here with Emacs.
Can you explain what you just did? Because I don't understand what the goal was.
Well, so remember what I did before was I found all the things. I made some stuff invisible. What I was trying to show was how I would go about finding the things. So what I do is I go through, find something that matched. Probably better would have been to get the whole line. There's a function line beginning position and another function line end position. So after I matched, I could have gotten the buffer substring of the whole line, and then I could make that whole line invisible.
Or turn it red.
Or turn it red, or do anything I want with it. But the point was that it's very easy to scan through a whole large set of stuff, matching things. So let me actually do that.
Now, could you bind this all to like your own little function and then just have it so all you have to pass in is the regular expression?
Of course, but the problem with that is that when you have lots of little functions like that, the time to remember where you put it, what you called it, and how to use it greatly exceeds the time to type in again by factors of hundreds. So,
and especially if your history saves a lot of history over sessions. So like if you close this Emacs window completely, this entire, and you restarted it up again, you would still have that in your history buffer, I assume.
No, there is no. You can arrange to save history like that, but that it isn't on by default, and I never do because again, you'd have to go back.
Right.
I do a lot of this stuff, so just searching for it is actually harder than just typing it back in again.
Right.
So, but the main point I was trying to say is that when you do these loop expressions, you have the loop part here. You have with files, that's one clause, or position equals search for, that's another clause, and while position, that's another clause. For name equals this, which I'm going to replace for buffer substring. Actually, the point is, you can navigate around as whole expressions rather than doing it as characters to edit them, and you're glomming together very simple things, and what you're getting out of it is quite complicated behavior. What I could be doing is I could be parsing these lines. I could be, getting them into separate strings, separated by spaces. There's a split string function built into Emacs. I could be taking those and putting them in a hash table, and then at the very end of the loop, going through the hash table and finding interesting bits and pieces. All of this stuff is what I do sort of routinely.
Right.
And you can't do it in other environments. So.
And I should point out that Kalman was the impetus for many users getting 64-bit Linux desktops in Ab Initio, because Kalman hit a point where he had individual buffers that were exceeding 4 gigabytes of RAM, and so hitting the 32-bit limit. And in fact,
wait a second,
Kalman on many occasions has Emacs buffers that range into the many gigabytes. So doing those regular expressions works really well, because if you've got a buffer with a couple 100,000 lines in it, you can at scale hide a bunch of crap you're not looking for and stuff like that.
So I think you're being slightly inaccurate. What I do, which is slightly different, is I have lots and lots of buffers. I have an Emacs at work that has 40,000 source files in it, basically the whole tree. And I do regular expression searches across all 40,000 buffers. That there's built into Emacs, there's this thing called occur. So if I say foo, it search, I found none. How is that possible?
But it only searched one buffer.
Because I only searched here, right? So if I say, there's also list matching lines is exactly the same as occur. That's what I usually use. Let's say message. So these guys over here, you can either click on them, or if you go over there and hit return on them, it takes you to that location. So if I go down to the next one, it moves down. Which in fact I didn't want to do, because it's getting me out of sync with my stuff. But
So what's occurring? Does it now? Because I
So-
thought Emacs.
but
well,
then you can also
maybe
do
this
multi
is
occur. So
Right.
multi occur is the same thing, but across all the buffers.
okay.
And you give it a list of buffers. So you can use buffer list, which is all of them. Foo, and that will get us a whole bunch of them. And so in this one here, it says we've got some in the foo buffer, in the buffer doc. We've got some matches in the buffer list itself. We've got some in shell. Yeah. And again,
Right.
each one of these, if I hit return on it, will take me to the appropriate line in that buffer.
It'll split the window and bring
Yep.
you over to that buffer. Now, but you have to have preloaded all those files in your buffer. Like I've
Right.
used.
There's
I've used
meta
prevent-
xgrep. There's meta xgrep, which will run grep as a sub process and do it on files that are on the file system. And it too, in the output for grep, if you do the same thing, it'll load the file and switch you to it. So you can do it
Okay.
either way. The reason I do it in why I preload them is that I have a bunch of tools that'll do things like not only find the line that I'm interested in, but see if it's in a particular surrounding context. So is it
Right.
in a method on a particular class, or is it in a, whatever. But the point is
Right.
that the grep part finds a good candidate, but the other part, narrows down, to the interesting ones out of all of the candidates, which is again much harder to do if you're just using the command line tools.
So I thought Emacs limited buffers to like 128 meg. Maybe I'm thinking Emacs 24, 25, 26, but I noticed you were on Emacs 27. I don't know if they've fixed that
So
size
it
restriction on buffers.
isn't which version of Emacs, it's whether you have a 64-bit Emacs or not.
Okay.
Like most Lisps, there's a fixed size for an integer in your Lisp, which is smaller than the word size because each word gets to have some tag bits.
Right.
And for a 32-bit Emacs, it's something on the order of 2 or 3 gigs. That's the largest single buffer you can have. So there, no position inside of a buffer for a 32-bit Emacs can be bigger than that. However, in a 64-bit Emacs, you're good. I'm running a 64-bit Emacs on Windows.
Okay.
Another question I had was, I noticed that you use Control N a lot, Control N and Control P.
Yeah,
Is
that's
there-
how I move around.
Is there a reason why you don't just use the arrow keys?
Because the arrow keys are off to the right, and I have to leave my fingers off the home row.
Okay.
I'm
But
a touch typist. I type very fast. I
But
like
your
my
pinky,
fingers-
your pinky must be like really tired holding the control key down the whole time.
No, it's the pinky isn't holding it down. The weight of my hand is. I how you would poke something. You just poke your pinky, then let the weight of your hand just sit there.
So do you have your control key to the left of the A key, and then you have your meta key between the A and control?
No, I have the control and alt exactly where they are on this laptop. The control is the left-hand corner key. I hate the ones where function is there. But,
yeah. And then alt is next to the space bar.
Exactly. And so
and you
control
got that
alt,
Windows.
I hold down with my pinky and my index finger
Yep.
while I'm doing things.
Okay.
And typically, if I'm holding on Control Alt, I will and have to do something keystroke on the left side of the keyboard. I might use my right hand to go over there, just because it's easier to just hold it down. But again, I'm not doing anything active to hold down the key. It's just the weight of my hand. I'm also a pianist, so one of the things you learn very early on is that the most efficient thing for using your fingers and hands in that sort of keyboardy fashion is to let the weight of your mass do most of the work and to be as relaxed as possible as much of the time as possible. So I'm not pushing, I'm not straining, I'm not exerting, I'm not contorting. I'm just using the weight of my arm, on a stinger, basically.
No, that's so. I remember, when I did Lisp back in college 30 years ago or so, it was cdr and car and push and pop and all that. So and over the years, having used Emacs for a lot, I've sort of learned a little bit about hacking Emacs. But I think my college Lisp experience scarred me enough that I've never wanted to learn Lisp.
Car and cdr are still actually terribly useful. The reason that Lisp has all these crazy things. You can take the C for car and cdr and the R for car and cdr and put as many A's and D's in the middle as you want. So if you want the car of the cdr, it's CADR, cadr. If you want the car of the cdr, it's CAADR.
Oh my God, will you stop?
And,
okay, so
and that's
I think we need to go back and explain, because I think some of these other guys are maybe lost, like I am a little bit on the exact difference of car and cdr. Because
so remember at the beginning I said that a list is made up of conses. So a cons has 2 pointers. The first pointer is called the car, and the second pointer is called the cdr. And those came from the 709, the IBM 709, which had an address register and a decrement register. And the Lisp implementation kept the cars always in the address register and the cdrs always in the decrement register. And so CAR stands for contents of the address register, and CDR stands for contents of the decrement register. But if you have nested lists, you're going to have to sort of navigate down multiple levels. And so having the combinations is much more compact than saying the car open paren car of the open car of the open paren cdr of the open cdr of the right with exactly the same effect. So I have sort of got myself a little mixed up by doing some of those multi-occurs. I got opened up places that I didn't intend to open up. So okay, so so we did this one, right? Oops. We did this one, right. So now we'll do this one. Okay. So I didn't get too far off. So this is an example of what I was telling you before. Let me just actually run it. So this is org mode. Org mode has these little code snippets. You can run them by typing Control-C, Control-C. So I just defined a function called split into panes. And what happens if I call that function, let's say 6. I thought I defined that function. Control-C, Control-C.
Split into n panes.
Right. Okay. So again, nice to be able to get it back. So now we've basically, gone into different windows. The next thing would be to open different login shells or other things in these different, buffers. So you go, call other window 1 to go to the next one. Do an rlogging command or a shell command or something to get the process going in this one. Then you'd go other window again. The calling the function other window is exactly the same as doing Control-X-O. Once you've gotten all of the right things started, you can do Control-X-R. Remember, Control-X-R was the register commands. But this time you say W, which says I want to keep the window configuration, and then you pick the register. So let's say Z. So now I can say Control-X1. Now I'm back to the way I was. But I can say Control-X-RJ to jump to a register. And I'll say I'll pick register Z. And that will put back my window configuration. Moreover, if I had shells in all of these things, I could go
Right.
to, say loop repeat 6, do buffer is, the buffer that's in this other window, truck through all the windows. And then to each one of those buffers, I could do something like this, which is, sorry, wrong buffer. I want shell buffer. So here I am in the shell buffer. I could say just insert dir. But that's going to just type some characters into this buffer. They haven't been sent to the shell yet. They're just sitting there. But I can say comment send input. And there they go. So that
And
sent
then
the
you
input
do,
to the shell and got the output back. Actually, you have to programmatically do something else to wait for the output to come back if you want to then parse the output. I just sent
right.
the input in, but
But you can kick make or something off on 10 or
all
12
of them.
different,
I can
all of them.
update all my sandboxes on a dozen different machines. I can start make on every one of them. I can while the makes are running, I can see has there been an error. I can search all of those buffers. It's because Emacs is accumulating all the data. Oh, and then the other cool thing, let me see. Let's see, add new. Okay, so what I just did was I added a hook. What this hook is doing is it's saying when output comes back, every time you see a new line in the output a timestamp. And this is an Emacs timestamp. It's in fact the output of current time string. And the thing that's nice about this is that, yes, I could have each one of the shells on the dozen machines output a timestamp, but they won't necessarily be coordinated. But if I'm building and testing on a dozen different machines, these timestamps are exactly the same because it's the Emacs timestamp.
Right.
So I can
They
say,
start from a known
this one
base.
failed over here at such and such a time. Oh, there must have been a network problem because they failed everywhere else at the same time.
Right.
So in fact, that there's in this code, there's a variable. I wrote this code. Datifying, which is a variable that controls it. So if I just set q datifying to nil, and I'll type another command, timestamping is off. A lot of the code that I have will actually search for things and skip over this date timestamp field. And of course, I could make it invisible too, so that it doesn't show up, but it's still there. Right. Moreover, a thing that I haven't done, but I've thought about doing, is I could put it as a property. So the line itself from here to here could have a property of my own.
Right.
Sorry.
You could have like a timestamp property on the first chunk.
Exactly. No, it would have to be on the whole range. Remember, properties span ranges of text. So that line would have the timestamp property.
Well, wouldn't just
Can I ask a question here?
Sure.
These properties don't actually go in the right?
The properties are in the buffer, and they're if you copy strings, they'll be copied with the strings. That's why I had to do the match string no properties to get rid of them. That's all that gobbledygook we saw when the first time I didn't do that. But they're not normally saved with the buffer. However, it's no problem to actually write them out. I have a function that I wrote for saving shell interaction. So one of the other things you can do is here we could be running this shell and we could be executing commands, but I could also be writing it to a file, and it would auto-save periodically, and the entire contents of the thing. And so if my machine crashed, I'd have up to the last autosave point still out there as a file.
Right.
And I have a function that I can invoke that will, for such a saved file, also save the properties. Mostly I'm interested in being able to do this Control-C, Control-P. So those properties that show where the input starts and ends for the previous command and stuff like that. But it can save whatever properties it wants.
My question was actually the opposite. Sometimes I want to see what's actually in the file. I don't want properties flashing in my eyes. I want to get rid of all that crap.
You don't see the properties unless you go look. You have to ask to see what the properties are.
Well, how do I turn them off then?
No, what Keith is asking for is he wants all of the prettification turned off in Emacs. He just wants
he wants all the font lock.
He just
mode
wants
off.
to see good old black and white.
Turn off font. Turn off font lock mode.
Green and
black. So all of those things are controlled by variables. So if you want to, apropos font lock,
toggle font lock mode. I do that all the time.
Yeah. Turn on font lock.
Okay, font lock. I don't know what that is, but I can go read the.
So
it's called, and it's there.
Emacs, toggle font lock.
Hold on, let me check because maybe I'm remembering it wrong.
Yeah, I usually do that all the time too, and I just thought you just ran font lock mode and it toggled.
Yeah, it's font lock mode. Sorry,
it's just font lock mode.
Because I turn it off most. I agree. I actually turn off most font lock because I find colors to be very distracting. Meta X font lock mode is to toggle it. There. Is that what you're looking for, Keith?
So now it's only black and white. If I do it again, how did that happen? Okay.
You hit the meta key. Or the Windows key.
Windows. Yeah, I must have hit the Windows key. So now I turn it on again, and now I get colors.
Does that make sense, Keith?
What I was going to say is when you say meta X, you can say meta P to get the previous meta X command that you got.
Right.
And go back, or meta N to go forward. There's also, so you can say meta R, which lets you type in a regular expression to match the history of the, match entries in the history. So if I had something that said food that wasn't on that matched that item, but you can get back an entry from your history from long ago.
No, I like that. Now that I'm learning the meta stuff or remembering it, or part of it is it's wonderful to learn some of this stuff and to see like the power and the amazing things you can do. But there's I'm a dumb guy, and so sometimes my brain doesn't have the memory bandwidth to remember all these funky characters. Plus, when I switch from Windows, then I have to go over to Word or Microsoft Outlook because that's what I use for work.
So I am actually running Emacs in Windows. About half of the time that I use Emacs, it's in Windows. So,
right.
And it's the same. All of the stuff I'm doing is the same. I have a base Linux machine, but I have a Windows VM, and I switch back and forth. This is the actual code for doing that date timestamp. You probably are not interested in it, but the add datafy function that I called, all it did was it added, comment, added the. Sorry. Keep typing the wrong thing.
Comment
down here.
What does comment stand for?
Communications interface. That's what the shell buffers and the
rlogin buffer.
The rlogin and telnet and all of those guys. FTP, all of those guys. It's an interactive talking to a sub process.
I googled that and got command enter something.
Sorry, what?
I googled that and came up with command, whatever it was after that. Communication command, same thing.
Okay. Command interface. Okay. Anyway, the comment pre-output filter functions. I'm going to push the name of the data-fi function onto that list, unless it's already there, and only when it's there, because many things about Emacs are different than different Emacs versions, so you have to sometimes be a little careful, especially if you go back to old Emacs versions. On the mainframe, we have an ancient Emacs version, and it was incompetently ported. So lots of stuff I do has to take that into account. Anyway, data-fi, these comment pre-output filter functions are called with a string, and you return a string. If you don't want to mess with it, you return the same string, but you can do whatever you want. And so what I'm doing is I'm seeing if datafying is true, that's my control variable, and I'm not in an FTP buffer, and that's because ng FTP and then later, what's it called? Anyway, the remote access stuff uses FTP buffers that don't want to have a timestamp in the front. It just basically gets the timestamp that I'm going to put on it. It loops across the string. As I said, loop does many things. Loop for X across a string. That's a keyword that lets you go across a vector. You can loop for X being the hash keys of some hash table. You can loop for X being for any variable. X is just the placeholder for something being hash values of a hash table, or you can do both at the same time. And this if clause here says, if this condition is true, do this following clause, otherwise, go on. So,
so why the magic number 10?
10 is the new line. If I type 10, you'll see that it says it's
Control J,
12,
right?
hex A, and Control J.
So if X, so you're doing equal L is language, or right?
EQL. Lisp has a bunch of different equality predicates. EQ, no L, is just, this is the same pointer. It only works for integers that are basically the smallest possible size, fixed number. EQL is the next higher thing, which says if this number could reasonably be interpreted as the same. So that will work for boxed integers or other formats where it's not going to be the exact same object, but it's going to be numerically equivalent. And then EQUAL is another higher level of equality, where things like lists with the same members at the top level that can be compared with EQL will do it. And then there's equal P, which will also say true for things like strings that are the same minus case differences. Anyway, there's a whole hierarchy of them.
Right. So you're looping over the string, and you're looking if
every time I get a new line,
any word in that string hits a new line, you're.
And what I'm appending is the list that's the result of this cons. So this cons is tacking a new line in front of, then basically getting all the characters out of the timestamp and the doubles and two spaces. I should have done that upstairs. I should have had timestamp do the concatenate with the two spaces up there, then I wouldn't be doing it all the time. And I'm collecting those characters, then I'm sticking the new line character in front, and that's what I'm appending through each time through the loop. Otherwise, if it's a regular character, I'm just append wants lists. So I can't say just put this character at the end. I have to give it a list. And then the coerce says take this whole list of characters and make it a string.
Yeah.
Anyway,
my brain's hurting. It's good stuff, though. It's good. You've taught me a lot, for sure.
So anyway, I'm going to try to get through these. Some of these are not going to be all that interesting, maybe. So one of the things that I can't demonstrate but which I have done at work. You can open sockets in Emacs. In fact, there's a special type of process object that's really a socket. So you can basically connect an incoming socket to a buffer and send the data from a buffer to an outgoing socket. And the reason this is useful is that you can do all sorts of low-level things. One of the things that I've done is I have a tablet that has Emacs running in Termux, and I wanted to get some files to and from it, but I didn't have any other useful stuff. So I just used Emacs, opened up a socket to receive the data, sent it with Netcat. It's now sitting in the buffer. Another thing I did is I used it to allow me to, I have two different sites, both of which have firewalls and which only allow connecting out. So I have an Emacs on one site and another Emacs on the other side. And one Emacs has two listeners and the other has two active connections. Right. And they're connected in such a way that if a listener connects on the listening side, it makes an active connection out to the other guy. Sorry, it doesn't make an active connection out to the other guy. It waits for the other guy to make an active connection in that's going to get hooked up.
Right.
And so then, basically the eLisp code just, passes things back and forth in both directions, which allows me to, have a client on as of a server on the other side, both crossing the firewall.
Sort of
I've done this for VNC to my laptop.
Right.
Anyway, another thing that you might not think your editor could do. Another thing that you might not think your editor could do is I once had a command, actually a sequence of commands that were in a script that I was running, and they did a bunch of moves. But they had the moves were move-I, and unbeknownst to me and the author of the script, there were a lot of files that it decided to ask about, like on the order of hundreds of thousands. And it was already running. It had already done substantial work before it got to this section. It was going to do lots and lots of work later. We didn't want to interrupt it. So I basically typed in this function, which then I made to be a timer function. So you can say run at time, and you give it a delta time from now or an absolute time. I'll say 10 seconds. And then a repeat. I don't need it to repeat. And so then you give it a function to call, and then an argument to that function, as many arguments as you want. Hello from timer. So that returned the timer object, but 10 seconds later, we should get at the bottom, I think 10 seconds was too long, hello from timer, because 10 seconds later, we called that function. And so basically, I made this no to MV a timer function that got called every 10th of a second and repeating every 10th of a second to get past that point. So it was already running. I didn't have to interrupt the shell script. I didn't have to type 100,000 ends. Now, another thing that I unfortunately can't demonstrate is at work, we have a database that has pictures of all the employees. And to keep up and know who's who, I have an Emacs drill program that shows the faces of all of them. And when you hover over a face, it puts up a tooltip with their name, their department, and whether they're, which part of the company they're in, which country they're in. And I use this as a slide, as a drill program, because what happens is if you click on it, it disappears. It becomes invisible. So if you think you know the name, you hover your mouse over it, it pops up. If you were right, then you click on it. If you were hesitant or you were wrong, you don't click on it. every time you click, it remembers that you've essentially declared that this person is a person you know, and at certain events it'll write out to a file, and the next time you use this program, it will basically automatically make those hidden, so you don't have to keep answering for the people you already really know. And moreover, it always goes and gets the newest batch, so new employees will appear. Anyway, it's a cool
I would
thing.
click on the ugly people.
This is simply so that you know their name and what group they're in and stuff like that. I wanted to do a similar thing as a demo here, and I started, but I didn't get it completely finished. I obviously can't show the one that's the one from there, but what I can do is I can show you the start, which I was going to do the same thing with Pokemon. So here we are. We're going off to Bulbapedia, bulbagarden.net. And we're going to, hopefully, if my network is working.
So while this loads, an interesting, this is cool. Kind of an interesting and cool thing that happened with Kalman's Joel program was one of our coworkers unfortunately suffered a minor stroke. And one of the things that happened was this minor stroke essentially erased his knowledge of people's names. And in fact, I showed up on a Monday and I was called to his desk and he said, "Hi, I know that we're friends. We've been friends for a long time, but I don't remember your name." And unfortunately, he had his minor stroke had basically blown out all of his names and passwords. So after we got him back into his machine and working, he actually used Kalman's drill program to sort of reteach him all of the people in his department and the people around him, and it was really effective for him to sort of get back the thing that he had lost. And it was one of those, a quick and easy way for him to suddenly gain back his knowledge of all the people that he had worked with. And it was kind of a cool and interesting moment to sort of see Kalman's drilling program used in a really neat and effective way.
So this was the start.
That's so very serious that I'm sorry I made jokes about this program.
No, it's fine, but that's awesome. Someone using an interesting tool to solve a real problem.
Well, I wrote the tool years before.
Uh-huh.
I mean, I wrote the tool for myself because I wanted to, I kept seeing new faces and said, what's this person's name? But anyway, this is the beginning of collecting the Pokemon information. And so what this did, actually, let me go find one bit. Oops. Wrong thing. I wanted this. Oh, let's type the wrong thing. There. So Emacs has a web browser built into it. It doesn't have any JavaScript support, so it's limited for what it can do.
Right.
But it can load a site like this. So artwork. Oops. Why did it not work? So yesterday,
Artwork.
I actually got artwork. It showed me an image there. Today, it's not doing that. Huh. That's weird. Anyway, what I had hoped to show is that if you position yourself on that image, there'll be a text property for the display property, which says display this as an image. So that this is a Bulbasaur, and the text that's actually in the buffer is Bulbasaur, but that region where the letters BULBASAUR is stored has this text property that says, by the way, display this as an image, and one of the values of that property is the actual PNG image of the thing. And as I said, I wanted to put it together so I could do essentially the same drill program using these images, but I didn't get far enough, and I don't know why it's not working today. It's a different
I
one.
blame it on Bill Gates. Stallman wouldn't write such crap.
Huh. Everyone writes
Ah,
crap.
there. So here we have some artwork.
Oh,
So if I go to the end of this line of artwork and go Control F to go move one character. Oh, so I can say character. No, so char after point is the current cursor position. See that the char after the point is the new line, and the char before the point is a space. Now I go here and go one forward. Notice the entire image is flashing. If I say char, sorry. I don't know where the character went.
You could datify it and you could add the date.
Okay, so char after point. Why is it? Okay, 73. That's an I. So this is an Ivysaur. So that's an I. If you the most rightmost thing, a question mark I says this is the character I. But if we say text, text properties at point, you'll see. Oh, help if I spelled things. We'll see that. Okay, so this is one of those cases where we want to go to scratch buffer. First of values, because I executed it there, and then we want to go and do this ellipsis. So you can see that we've got a whole bunch of different properties, like the URL it came from. But down here, you'll see the display property.
Right, the image data.
And the image data is one list where it says that it's the type PNG. The data is this long string. Control meta F goes forward a whole expression. Control meta B goes back, and it's a scale 1.4. And this is this displacement from the rest of the text. So to finish this, I would have to just take those images and put them in a buffer, and then add. One of the other things, you can see a key map here. That's another text property. This key map says if you type this character, it's going to call this function. So you can browse the URL. You can maybe probe and copy the URL. You can insert the image. You can browse it in a new window. And so, and this one here, the control mouse metaphor, control mouse 4 is a scroll wheel click, and that says increase the size. And you can add your own things, so that's how the properties for putting it in a tooltip and the properties for making it invisible, running the function that when you click on it makes it invisible. This is where you put them too. Anyway, that may be enough for that.
Here's a question.
Sure.
I tend to run a putty on my Windows box, and I SSH around the world, and I end up usually on what I call a jump box, and then I'm using screen to get between multiple windows and stuff. So assuming I can wrap my brain and my fingers around it, it almost looks like what I should be doing is running Emacs on my Windows box and using our login mode to get everywhere around the world. But can I display, if I'm running a remote process, like I've logged into a remote Linux box, can I display graphics back or not into my Emacs window? You know what I'm saying? Into that buffer.
So no, if you've got an R,
that's what I thought.
If you've got an R, but you can't with screen either.
I know I can't. But But that's where I used to use NX or VNC to do a remote desktop or remote desktop command to be able to look at a graphical remote desktop. And that's one of the reasons I still use SSH everywhere or PuTTY windows, is because I can SSH into my home machine. I can SSH out to a mail server. I can
Right.
manage my boxes. But some days, like, it would be nice to be able to like pull up a Pokemon graphic image inside a buffer and be able to look at it. You know what I'm saying?
Yes, so it's a fundamental network problem. If you're
Right,
if you have an
absolutely.
SSH connection, it's just a stream of bytes, right?
Yep.
And while it's certainly possible to send that image data across,
Right.
and it's possible to write Ellipse code that recognizes that this is an image data and then displays it in your Emacs, you'd have to write that. There's nothing.
No one's written a VNC server?
Sorry, what? There's no VNC written in Emacs. There is a server, I think. I vaguely remember one from a long time ago that didn't work very well. I don't know if it was abandoned or if it got improved, but there's literally thousands of Emacs packages. There's two major repositories of Emacs list packages and a half dozen smaller ones, and you could spend your entire life and not get caught up on what the state of things is. There's things that allow you to edit with multiple cursors. There's just large numbers of things. Most of my uses of it are things that would help me do my work. So I want to be able to collect the information that's coming back from the screen and do things with it. So, for example, one of the things that I do on the mainframe is we have a storage system that has many drives. The mainframe has this sort of compatibility for its drives, so they look like the mainframe drives from decades ago. And so there are lots of them, and they're small, and getting information about them is a tedious business. And you can do it with a 3270 terminal, but you have to do it each one separately and multiple screens for them. So I have an Emacs process. There's a X3270 emulator. There's an interface program. Actually, that's down here. Oops. There's an interface program called X3270IF. You type commands at that interface program, which has either a pipe or a socket connection to the X3270 that's actually talking to the mainframe. You can say, put this character here, move the cursor here, dump out what's on the screen, hit the send key, all that sort of stuff. And so I have a whole ELIS scripting set of things that allow me to execute, again, simultaneously on all if I want to, command, scrape the information that comes back and organize it nicely and then display it well. So, along the same veins, I have this one. So there's only, as far as I know, there's only PS3, the executable on Linux. But a lot of times it's useful to have, sort of to get an indented list of processes, by parent. So what I wrote was a little bit of ELISP that takes the output of a plain PS command, parses each line. It's getting the PID and the parent PID and all the other commands. It's taking each line and basically putting the values into a hash table, and then it's going to find the lowest numbered, not already printed, no child, no parent number, and then all of those children, marking them as printed, and then keep doing that until it's marked everything. And so that gets me a nice indented process listing. But again, the work is being done in Emacs, not the platforms. And so it's because we have AIX machines and Solaris machines that don't have PS3 and the mainframe.
Cool.
Okay, so I already talked about this one.
How do we do occur again across multiple buffers?
Multi-occur.
Oh, multi-occur.
Great. So if you type it as a meta X, it'll prompt you for all of these things, which I never do. Usually instead, so there's a function called buffer list that returns all the buffers. But what I usually do instead is loop for buffer for B in buffer list when and buffer file name of B. So that's only going to do file buffers. So my help buffers, my apropos buffers, and stuff like that. So that's just saying that there is a buffer file name, and then I could do something like search foo in, or actually el in buffer file name of B. So only when those two conditions are met, that just collect B. So that's going to go through all the buffers in the buffer list and select out the ones that I'm interested in. And then I can say, all of those search for require, they're all going to probably have it. And again, it would be harder to remember where a function was that did something like that than to just type it in. Okay, and then org mode, which I've been using sort of minimally, but org mode is enormous. It allows you to keep track of your tasks. It allows you to keep track of your calendar. It allows you to take notes like this. The person who invented org mode realized that your to-dos come out of your tasks. So if you just type Control-C, Control-T, that becomes a to-do. You type it again, it becomes done. If you type it again, it goes away. You can change the states that it cycles through. You can do things like clock in, Control-C, Control-X, Control-I is clocking in. That says, oh, I'm starting this task. And it remembers that you started it now. You can then, if you go to another task, you can say the same thing and it'll clock you out of this task and clock you into the next task. Or you can just say Control-C, Control-X, Control-O to clock out and have time that's not accounted for. You can add just date and timestamps to arbitrary things. And there's this thing called org agenda mode, which goes through all the org files that you've defined to it and picks out the calendar entries and things like that. So you can have meetings and tasks of various projects and to-do lists and things like that. To-dos, you can have separate sub pieces that have check boxes that you can turn on and off. It's enormously complicated. I use it for very minimal stuff, but it's all written in eLisp.
Right.
And finally, last thing. Actually, before I do that. Built into Emacs, although Red Hat removes it from their version. Anyway.
Yeah, the owners of the trademarks for Tetris were very litigious about that, protecting that.
Right.
Anyway, so that's pretty much it. If I can not get in my own way. I got in my own way.
This has been awesome, Kalman. Learned a lot tonight. I mean, I get yelled at. I use VM to read my email and write email, my personal email. And I use SuperSite to, yank in, whoever the person I'm replying to's email and put their name in front of their paragraphs of text and stuff. And everyone in my, my Boy Scout troop yells at me and laughs at me because, it looks great on my screen, but then when they read it on their phone, it gets word wrapped in really bizarre spots. and they're just like, oh yeah, we know it's John when it's a random reply because oh, I hate people who reply up top, but it's the Microsoft way and I can't get away from it.
Yeah.
Top posting.
Yeah, one thing I didn't mention is that if you have lots of large, long lines, which I often have, you can set truncate lines. It's a variable per buffer. And what that'll do is it'll basically make the lines only go one line, and then you can scroll to the right to see more.
Right.
And then combine that with making parts invisible. I was working on a machine that had hundreds and hundreds of Java processes with humongous lines for the
class path.
The class path. And so what I did was I did that same loop search for class path, remembered that position, searched for the next space afterwards, and made that whole bit invisible. And so that brought the lines now that you can see the end.
Wow. Yeah. God, yeah, I probably would have just pushed it through awk or set or something and pitched at it. Yeah.
Well, so the thing is, if you do that, you've now thrown the information away. If it turns out that I found, if I found one that was peculiar or behaving strangely or stuff like that, I could put back its class path and look for it, or I could put back several of them and compare them using MEDEX compare windows to see how they differed.
No, that's awesome. I think that's a great feature, and you obviously, I think, live inside Emacs 99% of the time.
Pretty much.
Yeah. And you're like the 1% to my 1%. I live in Emacs for most of my editing and text editing and stuff and email and things, but you live in it for your entire life, which is awesome.
Yeah, I have to say that I'm in that same boat, John. Kalman will come down and stand over my shoulder, and when I'm using Emacs, and he's like, why are you not? What are you doing? And invariably, I learn two things in the moment that I'm sitting there, because I'll do something and they'll say, that's the most inefficient way you could possibly do that. Here, do this, and it's like, oh yeah, okay, fair enough. And part of that is, like I said, I'm kind of sure that Kalman's actually a Lisp machine.
Emacs is sort of a mini Lisp machine. I don't know if you guys know about Lisp machines, but they were invented at MIT not too much later than Emacs itself, which was also invented at MIT.
Because Emacs was Tico first, unlike
ITS Tico. So the Tico that DEC had was the baby Tico, but Tico got steroids, and the first Emacs was done on ITS Tico. The second was done, I think, for Multics and was written in Lisp. And then there were a few Emacs lookalikes like Gosling Emacs.
Yeah.
And then Stallman went and wrote new Emacs. Then after a number of years, X-Emacs forked off and added a whole bunch of features, which it took new Emacs most of a decade to get back. Didn't get all of them either, but
I think 2 decades. It really stagnated for quite a while at one point. Emacs.
There's lots of activity on the Emacs front. Not all of it good. So one of the things that I did when I was doing Advent of Code is that I wrote almost all of the functions in Advent or Code are basically loops, big loops. Because loop macros, invocations of loop, and loop is exactly the same in Emacs as it is in Common Lisp. Now there's some things around the edges that are different. The representation of characters in Emacs Lisp is different than in Common Lisp. So I have to do some circumlocutions, but by and large, with a couple of additional functions defined for Common Lisp, I can load my Emacs Lisp Advent of Code things into a Common Lisp and run them. I didn't used to be able to do that because before Emacs 27, Emacs didn't have big nums. So it did have the calc package, and you could do infinite precision arithmetic in the calc package, but you had to write code differently. It wasn't just adding and subtracting and multiplying and dividing. But in 27, it does have big nums. And so I got all the stars that I got, which I think was 35, 40, something in that range. I'm going to finish them sometime, but
That's been my goal. I'm stuck at 4 just because I work on it for 10 minutes a day and then I disappear to other stuff. And so it's going to take me till about 2024 to get it done, I think.
Well, you can do all of the previous years. So.
Right. Oh yeah. But I'm doing it all in Perl because that's the language
Perl.
I feel.
Now that's a challenge.
Well, it is in some cases, right? But I wouldn't want to do it in Emacs, because I don't think in eLisp. It is someone's doing it in BASIC, I'm sure.
Awesome.
Someone's doing it in Pascal, and someone's doing it in Excel. There's a million different ways to do it. Someone's probably doing it in Sed and Office.
Absolutely.
I pity the poor guy who's trying to do it in like 8086 assembler or something, or 6502 assembler. Oh my god. But
just for the infinite precision arithmetic, you'd have to have many thousands of lines of code of assembler.
Yep. Who do we need to mute?
Anyway, does anybody have any questions?
Yeah, one question I've been thinking about all night long watching you do this stuff. Has anybody ever thought about putting a GUI front end on that thing?
Sorry, I didn't catch all of that.
He wanted to know if there was X Emacs.
So this is Windows GNU Emacs that I'm running. I don't know if there was a Windows X Emacs. I have run X Emacs on Linux and on different Unix, and it's pretty much unmaintained at the current moment. There's nobody doing any work on it. So and it has some bugs. It doesn't have big nums. All of the image handling features are different. So I mean, there's image DRED.
Right.
Is the version you're running on Windows a terminal-based Emacs, or is it like the?
No, it's a Windows. It's a GUI Emacs.
Oh, so it's actually using Windows native GUI.
Yeah, that's the only way. That's the only way we would see that image.
If you do meta X menu bar.
Yeah, I can do that.
I just found that there's a Wayland port for Emacs, or at least was discussion about one.
Is it menu bar mode?
Yeah, it might be. I don't remember. I toggle it off on all my Windows because I don't use it.
Yeah, I toggle it off too.
It could be toggle, and this is where it's sometimes inconsistent. It's toggle menu bar or menu bar on or something, and I can never remember what it is. Hold on, maybe I can figure it out from my .emacs file.
Now, the reason I was asking if you were using an X11 based Emacs is that font string you brought up earlier was an X11 font.
Yes. It turns out that a while back they were all different, but it got regularized so that everybody uses the same font specification nowadays.
Because X11 fonts are dead pretty much with client-side font rendering.
It isn't actually an X11 font. It's just a name.
Okay.
It's in that format. These are using true type fonts.
Oh, there it is. Menu bar mode. I think if you just do menu bar mode.
That's what I tried. X menu bar mode. Okay,
there. So now you can see how he's got the file, edit, options, buffers, tools up top. So you can do point and click a little more on your Emacs. But most Emacs users would rather die than use a mouse.
Right.
Mostly because it's so much slower. But it's possibly a way to learn where things are.
I mean, for example, if you were browsing around here, you can click on this to get the thing, which might be faster if all you're doing is reading.
Right.
But certainly typing things in and mousing aren't terribly compatible.
Yeah, they each have very different strengths. Right. Right. There's some things the mouse just wins at, but yeah. No, I mean, I actually still have like micro Emacs, installed in various places. I think even
well,
on my
so
Windows
all of
box.
those Emacs lookalikes only are lookalike at the level of keystrokes. They aren't. They don't
exactly. And that's enough for quick and dirty editing half the time, just so I don't have to, do Notepad for like real. Like it can do like paragraphs and end of word and all that stuff, and all those keystrokes are just enough to make it easy to do edits. If I have to do big edits or, and again, I'm not living in it like you do. Yes, then I go to a real Emacs. But if I'm just editing a whole bunch of text, Emacs key bindings are just quick and easy for me to do raw text editing, for documents or writing stuff, Markdown or something. Where if I try to do it in Notepad, I can never remember how to get to the end of the line, and all the shortcuts are totally different. And it's like when you go up to help someone, a new user, he's doing something different. He's got his mouse on the left hand because he's rebounded all to work with his left hand for his mouse.
Mm-hmm.
Or that one crazy guy who has a Dvorak keyboard with blank keycaps.
Yep.
And just sits there and laughs at you when you try to help him and show him how to do stuff. Or, the work keyboards where they just give everyone different keyboards and, the control key moves around the keyboard randomly. It's just like, you've definitely, Kalman, I do want to thank you because you've definitely, I think, got me a bit more motivated to try and use the Alt key. And maybe I will be able to retrain myself to use the Control and Meta keys down on the bottom level of the keyboard instead of up top. But we'll see.
So if you want to see what that fancy title code looks like, I could show that to you.
Sure. I won't understand it, but
I thought I could show it to you. I thought I had it in a buffer.
what happened? Why am I not seeing your full window anymore?
I'm seeing the full window here. So.
Oh yeah, no, you're good.
Well, I think when I toggled the menu, it made it.
Oh, it made it taller. That's why it's been pushed down on the Jitsi screen. So menu bar mode will just get rid of it again.
Oops. That's interesting.
You crashed it.
There it goes. Yeah.
So what Fancy Title is doing is it's calling this test4 on a bunch of strings. And the test4 is in this KRA file. And what it's doing is it's basically going to place takes the strings. These are the strings that it's going to display,
Mm-hmm.
and it's going to find out the size of the window in characters and make basically an array that size. It's going to place the characters in random positions, and then it's going to go on this move the character from where it is to where it wants to be, sort of in a random fashion until it's all back there. And before it did that, it colorized the strings. So it made some bits green and some bits blue and some bits. So this one here, this blue part, it made the whole from eLisp through the parentheses blue, and then it put the parentheses back to black. And then it calls this on it. And then after 10 seconds, it just killed the buffer. So that's why it disappeared after 10 seconds. So again, it's not hard stuff. It's all basically built into Emacs. It's just you just get to call it.
No, that's really awesome. I hope actually you'll be happy to share this with us.
Sure, I can share this.
Your talk, just because I'm sure I could mine this for little hints, and then of course I need you to come to my house and just stand over me for about 6 months to really get me.
The only difference between that fancy title and fancy close is that it's different strings, different places in color, and this one doesn't do the kill buffer at the end, so it'll sit there forever. And it's very funny because each time you run it, it's going to have a different length of time before it finally settles and puts everything in.
Right, you've got it sort of starting out at a random walk, and then it's slowly consolidating.
I put them in random places, and then I march them towards their destination.
That's cool.
You're most of the way to the matrix screen. You can just do that.
Yep. Oh yeah, you can certainly do. So modern Emacs has SVGs, so you can actually do drawings. It's not the slowest thing. And of course, you have images. You can tile your entire screen with images. So you can have a large image chopped up into small tiles.
Boy, I really wish I could. I really wish Emacs had a way to like do a remote Emacs with GUI stuff. I know.
Well, so
because when you do your multi-window and you split it up into 12 windows and you
that works on character Emacs. That works on character.
Exactly. That's exactly what I live in is character Emacs 99% of the time.
Yeah.
There's that point of the time where it'd be nice to be able to do an Emacs to open an email with GUI images. Half the time I run my own IMAP server for mail, and I usually read it in Emacs, and I ignore all the images and all the JavaScript. But every once in a while, I'll pull out my phone and poke at the image so I can go, oh, that's what they're showing me.
Well, I mean, if you can save the image, the email,
right. And I do that
on a file, then you can read it into your GUI Emacs and display it.
I know.
And you can automate that too.
Yeah. Definitely. So thank you very much, guys. I got to run. I got to go talk.
I'm going to stop sharing my screen. I stopped sharing my screen. Okay.
Oh, now we can see what you look like, Kalman. Awesome.
Thanks a lot, Kalman. That was really, really, really cool.
Sure, no problem.
Yeah, that was fun.
Great. I'm glad you think so. There's probably as many other extra things that I didn't think about. I mean, Tim asked me to do this on Monday, I think. And I've been fairly busy in between.
Actually, I think I asked you on Tuesday, but sure.
Okay. So I didn't have a lot of preparation time. I would have finished that Pokemon drill program.
I'm actually very impressed. I think you have such a huge mental map of Emacs and all that unconscious knowledge that you can pull up and do all those evaluations, like sort of how like I can pull up maybe some Perl stuff occasionally or SED stuff. Everyone has that their mental toolbox they go to, and it's inspiring to watch what you do with Emacs as and Lisp as your mental toolbox. I think it's really interesting. It may not be for everyone, and other people may disagree and stuff, or have their own preferred tools, but I think it's eye-opening to see what you can do.
Anyway, I'm glad you enjoyed it.
Yes.
Yeah. Yes.
Definitely inspired me to up my Emacs Lisp game and maybe try to do some stuff with it. So
Cool.
Have a great night, everyone.
Yeah, well, like I said, I don't know if we want to call it a night. Thank you for your time, Kalman. I really appreciate it.
Sure.
We are recording this, and so I don't know if there's a way I can stop the recording now. Let's see if I can say stop recording.